Hi, we are very happy to be part of the SaaS Global Forum. We are from Core. We are a platinum SaaS partner based in Raleigh, North Carolina. I'm Ajay. I'm a VP of Data Science at Core Compete. I have two capable colleagues who are data scientists with significant SaaS expertise. We all did this project of implementing SaaS Forecast Studio for an e-commerce retailer, and that's what we are going to focus on today. The overall session flow is that I'll provide an overview. I'll show how the production system for forecasting progresses. I'll talk a bit about the data. We'll talk about pre-processing and moving holidays, how we configured Forecast Studio, and what were the post-processing and accuracy reporting steps, and then we'll conclude. So the overall project was for an e-commerce retailer with multiple websites. Um, the expectation was to create an automated system using SaaS Forecast Studio to create a systematic, scalable, and science-driven product demand forecasting system. We use SaaS Forecast Studio and SaaS Forecast Server procedures for the data science work. For data ETL, we used SaaS Data Integration Studio, and we used the Schedule Manager for automation. Our goal was to create automated forecasts at the style, color, size. So it's a highly granular product hierarchy level forecast at for each website and for each week for the next 52 weeks for a large selection of departments which were in focus. There are a large number of benefits that we were expected to deliver with SaaS Forecast Studio. And one of the big ones is that for large scale automated forecasting, SaaS Forecast Studio is a highly capable system. It has a graphical user interface for users to work with. It covers a large selection of time series families of models. And the biggest benefit is that there is an automatic optimization which which makes both the data science work as well as the project highly efficient. It covers ARIMA, unobserved component models, exponential smoothing, and intermittent demand model, besides models for these. It's event handling, hierarchical forcing and reconciliation, and all the reporting and other functionality in the are also great strengths, because of which the client wanted this forecasting system to use SaaS Forecast Studio. We delivered a production system on AWS where the whole chain from data update to delivering the overall forecasts was supposed to work in automation on a weekly basis. So we had data update. There were several steps in data preparation that I'll talk about in more detail. We had configured Forecast Studio, which would run and pick the right models automatically and reconcile across the hierarchy. There are post-processing steps before the forecasts were delivered, and then we had some custom accuracy reports. The data itself covered sales as well as inventory. We had product information and product hierarchy, which were useful for the forecasting engine. We had future price data and website views, also clearance flag and SKU segmentation for some work that was involved in reporting. The data-wise, we had a mix of different kinds of weekly rate of sale. As you can see on the top right, we had a large number of series, about half of them in count, which had a rate of sale of below 2, but they accounted for only 8% of revenue. On the other hand, we had less than 10% series, which accounted for almost 70% of the revenue. And those obviously used different kinds of models, but it was all automated within Forecast Studio. From a product life perspective, we had a mix of below 6 months, 6 to 12 months, as well as more than a year or more than 2 years of data. There was significant sales variability and price variability in the data, which we were cognizant of when we were evaluating accuracy. And as the chart at the bottom right shows, that there was highly seasonal and really sharp peak around Thanksgiving and Christmas, which was important from a modeling perspective. It's very important to know what exactly we'll be forecasting. Based on clients' expectations, all SKUs which had an end date in the future and the first sale date in the past, and they had some activity in the last year, they were all expected to be forecasts. And these were the SKU and websites that we actually used to send to the SaaS Forecast Studio. We made certain adjustments for lost sales. It's very important that we not forecast sales, we forecast demand. So as this chart on the right shows, you can see the maroon is the adjusted value and blue is the actual value. So we can see that whenever we have no inventory, the green bars show presence of inventory, and the lack of it shows out of stock. So when we are not in stock, the sales are zero. As you can see, the blue line touches the x-axis. And we need to replace these with certain reasonable values. So what we have done is we have used the most recent 2 weeks of positive values. And you can see that we did not fill it with the same number. The first one, it's a low value. The one on the right is a higher value based on the recent values, so that the loss sale adjustment is meaningful. We also had certain additional conditions like not filling a long stretch of zeros or ensuring that they have significant inventory or sales, so that we are not creating demand where there was none. So overall, more than 3/4 of the series had some adjustment, and we increased sales units by 20% and the sales amount by about 15%. All of this was in collaboration with the client, so that they were happy with the overall loss sales adjustment that we did. We had some predictor variables. In retail, price is very important. Our client had a weekly future price feed that we were able to take, and as part of pre-processing, we used this price feed to create future values of prices. And wherever the price feed did not extend to 52 weeks, we used the last known price. For history, we did not use this feed. Instead, we used the more reliable average price for history. We also had website views at a slightly higher level, not at size level or SKU level, but at style level. And we use that information as a predictor variable as well after some smoothing. Obviously, we don't have website views for the future, and we use the stochastic option in Forecast Studio to make sure that it's a valid independent variable. So as a pre-processing summary, we created a complete history. While the Forecast Studio can accumulate data, we did it explicitly so that we are able to make adjustments for lost sales and do other pre-processing work. We created the predictor variables, and the client did not want to predict clearance sales, so we used the clearance data to make sure that we have removed clearance sales. An important feature of Forecast Studio is the ability to model holiday effects, particularly moving holidays. So we modeled this in Forecast Studio, and Easter is a very good example where it falls in different weeks in different years. So the purpose of this modeling is to make sure that we use history data to capture the right effect, and then in the future put it in the right week, so that the event effect is modeled correctly in forecast. So this is extremely important for retail. Forecast Studio has an ability to create all of this in the graphical interface, but there's more flexibility in the backend forecast server. So we use proc HPF events. An example is shown here where Thanksgiving is already a keyword, so the dates don't need to be put explicitly. And we use a temporary correction model to make sure that for the previous 2 weeks, we are able to create a model.
So SaaS Forecast Studio has a capability to accept configuration from UI and backend. So backend macros has a wide range of utilities to create, delete the projects, then updating events, models for the project. Various options are available for FS Create, which is used here to create SAS Forecast Studio projects like variable settings, hierarchy, aggregations. We have used specific variable settings for the input variables, like the coefficients are negative for the prices, then only it should be selected, and positive coefficients can be ignored. In terms of that, for aggregations, average aggregations is used because there are lots of series available in the history, and which are starting at various points of time, which makes it unequal while getting aggregated at higher level. So average makes it more sensible to use for the aggregations for higher levels. Similar to that, the reconciliation method has been set up at the department level, where the disaggregation is set up for the proportions, so that at the lower levels, forecast is getting adjusted based on the its sales units proportions. Similarly, there are lots of similarly there are lots of settings available which needs is required. Various tunings can be done in SAS Forecast Studio in terms of making the best setting for our SAS Forecast Studio project. For example, we wanted to select average prices versus discount being applied for the product. So with this experimentation, we have selected average price over discounts. uh, in in field statistics, in sample versus holdout samples is been tested. Holdout sample generally works best, but as due to the higher variable data, holdouts results were not satisfactory, and that's why in sample fit has been selected. So similar to that, various decisions has been made for the reconciliation, error criterion, and transformations. Forecast Studio supports all kind of forecasting models in the family, from that family: ARIMA, UCM, ESM, IDM, and Ensemble models. ARIMA has its extension models also available, which are ARIMAX, and then is specific IDM models are important for the intermittent demand predictions. Here, SAS Forecast Studio optimizes its parameters based on the internal tunings, and massive parallelization available in the SAS Forecast Studio makes us handle the thousands of series in each project. So that's the kind of really a good advantage of SAS Forecast Studio over other tools.
Post processing is important so that the forecast results that are going to the downstream are good and reasonable. And coming to the exceptions handling, there are exceptions like missing values or the unreasonable high values and the extreme values. All these exceptions are replaced by the rule based forecast by using the recent trend and the seasonality. And the next one is the prediction error adjustment. Prediction error is important for the downstream applications. So generally the large predictions errors generally occur whenever the forecast is small. So we are going to replace those large prediction errors using the prediction error analysis by capping them to a reasonable value. And the third one is the price based adjustment for the forecast. If you see in the graph here, there is no price variation in the history. Since there is no price variation in the history, the model doesn't take the effect of the price. But in future there is a change in the price. There is a requirement from the client that it should varies according to the price. So we use the price elasticity that was given by the client to adjust the forecast in the future. If you see in the graph, if we didn't consider this price change, you can see that blue line. But by considering this price change and by using the price elasticity, we adjusted the forecast, which we can see in the orange graph. Yeah, and the important thing that here is the custom accuracy reporting, where we measure the performance of the models that we generated for the forecast. So here the custom report what we are created are used by the forecast analyst for the review. So the main accuracy metric that we are using is the weighted MAP, which we are using revenue for weighting the things. And the time horizon here we are taking is like 4 weeks ahead of the forecast, which was taken cumulatively and then compared with the actuals of those weeks. And here another important metric that we are providing is the forecast value added, which gives how our the model is performing compared to the simple forecast. And to make these accuracy reports meaningful and fair comparison for the performance, we are considering the two errors. One is the price error and the other one is the availability error. Price error is like if the actual price is varied more than the 5% compared to the price that is given to the model. So we are dropping those series while calculating this accuracy. And similarly, availability error, if there is the item is out of stock, and since the item is out of stock, the actuals will be less than what we forecasted. So we are dropping this while we are generating those forecast reports. And the main important thing here is like we are providing different types of charts. One is the cross tabulations of metrics with the magnitude of actual sales and the product life length, weekly rate of sale, and the client product segment. Here the importance of these cross tabulations is like, for example, for actual sales units, if the actual sales units are less than 5, our MAP may be around 60% to 70%. But whenever the actual sales units are more than 10 or something, then we are getting the accuracy of around 30%. Means MAP values around 30.
So what we have done through this presentation is to show you how we implemented SaaS Forecast Studio for an e-commerce retailer. We've taken you through the whole project cycle, from understanding the client requirements and the data to making sure that Forecast Studio is configured well. And its strengths in being able to configure it from either the front end or the back end was useful, because we use the backend to make sure that we have automated batch runs. Forecast Studio is extremely powerful in the kind of algorithms it can use and how it automatically optimizes the parameters. So we use this, and you saw that a range of different models were used for the forecast, justifying the large model set. This kept the project very efficient because all of this tuning could be done by varying the different parameters. Finally, Forecast Studio's ability to work across hierarchies and reconcile them and model events are extremely efficient for a project. Doing any of these manually is very expensive for both a project and effort. And all of these do improve the quality of forecasts. Finally, we used the SaaS programming ability to make sure that the pre-processing and post-processing for the data are appropriate, they meet the client's requirements, and they give the clients the confidence to improve adoption. So leading to a very successful implementation of Forecast Studio. Thank you. So we hope that you found this presentation on SaaS Forecast Studio useful, and my contact information is below.